Hey y'all, welcome back. Today's project is going to be a customer-owned KFX450R with a starting issue. Now he's informed me that he's replaced the starter, solenoid, the battery, the button, just about everything, and this thing just makes this crazy noise. Now he also said that if you bump start it, it will start and it will run. It has a hesitation mid-range somewhere, so we're going to get into checking that out as well. Stay tuned. Now, when it comes to diagnosing issues with a starting system, we want to start at the source, which is going to be the battery. He did say put a new battery in it. We're going to go ahead and check to make sure that we have the 12.6 volts, or at least over 12 volts, and also see what the voltage drop is when we press the button. Now, things to keep in mind on a starting system for anything, a car, motorcycle, jet ski, it really doesn't matter. The starting system has two separate circuits. You have a low current circuit and a high current circuit. So basically, coming from the battery, you have your large wires that go to your starter and your ground. Now, if you were to run those large wires up through a switch, first of all, it would be pretty inconvenient, and that switch would have to be pretty heavy duty because these starters do pull a lot of current. The way they get around this is they use a starting solenoid. It's an electromagnet switch. So you have a low current circuit, which feeds your button, feeds the coil to your solenoid, and what that does is it closes the circuit on the high current side, which allows the current to flow through the solenoid to the starter. So by pushing this button and getting this vibration, I know I have a complete circuit through the solenoid into ground. However, we are going to check voltages there to make sure that it's getting enough voltage. What I don't know is whether or not we're getting 12 volts through the high current side. And that's how we're going to test this thing one at a time. Again, like I said, let's check the battery. All right, so I've got my meter set to DC voltage. I'm going to go ahead and check this battery. Red to positive, black to negative. Well, look at this cable here. This could be a very short video. So we've got 12.8 volts. Let's go ahead and kick that key on. 12.6. Everything still looks good. Let's go ahead and hit this button. And we are dropping to 6.9 volts. First thing I want to do is go ahead and tighten up these battery connections. All right, we got that snugged up. Let's try this again. It's better, 7 volts. All right, I'm gonna hook a jump pack up to this, give this battery a little extra boost. All right, that didn't do it. We need to move on to more diagnostics. Next thing I'm gonna do is go ahead and check voltage up at my starting solenoid. So this here's your starting solenoid. This is your low current side, which is the control side of this relay. And then these larger wires are one's coming in from the battery, one's going out to the starter. And I'm getting battery voltage up to the solenoid, which is great. Now we're going to check coming out of the solenoid. And we are getting 0. So next thing I'm going to do is I'm actually going to just jump these terminals out with a screwdriver. Be very careful, this is going to spark, and you have fuel right here, so we just definitely want to be careful about doing that. What this is basically going to do is act like the solenoid and jump these two terminals out, giving direct power to the starter. Okay. So this wire runs down and goes directly into the back of the starter. This is the feed for the starter motor. So what I'm going to do is take this wire off here and check our voltage. Now we're not going to be able to get into this in this video because there's no issues here. However, this is a power feed as well. So the battery feeds this solenoid. This solenoid has a main fuse, and then it also feeds power out to the bike through this connector. In doing so, it feeds power up to your button on your switch, which once pressed will feed power back to one of these terminals, energizing this coil. So if you have a situation where you have a good battery and you have good power up to your solenoid, at that point there, you're going to start testing wires, looking for loss of power up to your button. I've got a pretty strong feeling that this starter is internally shorted. Let's go ahead and hit the button again with this disconnected and see if we're still buzzing or we're just going to get a click. And that's what we want to hear. Now we'll hook our voltmeter up to that starter wire and let's get a reading. When we push the button, we should get battery voltage. So we have 100% determined that this starter is internally shorted. You can see this terminal here is just pulling right out of the back side of the starter. So this feeds the windings of the starter. If this terminal is touching this metal, you've got a dead short circuit. Now there should be an isolating washer here, and it's just not here for whatever reason, and that's going to be the problem. The starter's probably okay. So these are the brushes for the DC motor, and they're just pieces of carbon, and what they do is they transfer the electricity to the commutator of the motor and make it turn. But this is not really going to be an electrical class. So it's as far as we're going to go there. So this is plastic in here, which is fine. And the electricity will come through and energize these brushes right here. But the problem is they've got these O-rings on here that keep the shaft from touching. But as soon as you put this washer is essentially just grounding this out to the case. So I think I have a piece from like an RC car, which is a slipper clutch, and I can cut it to this dimension and make an isolator so we can fix this starter. So this material is like a soft rubber, and it is an insulating material, or I could use a piece of like gasket material like this to make it. In fact, I think I'm going to do that. This is a little bit thicker. So that's all we need, is just enough to isolate this washer from the metal. So before we put this back together, we want to make sure we have no connection between this stud and this outer casing. So we're in good shape now. Put this thing back together. Alright, well, since my jumper is dead, we'll just use the bike's battery. Hook that back up, touch that to ground, and we'll go ahead and hit that button. Alright, let's hit that button. Alright, starter's turning now. Onto the reduction gears. Some kind of issue in there. So here's our starter gear, and this is our idler gear down to our one-way clutch. You can see the starter gear is turning fine. Now what that gear does is it drives this gear, which is attached to this larger gear, and that transfers the power down to this gear. So let's see if it's not splining up on the starter or what. Okay, so this gear is turning. Alright, so as you can see, it's driving this gear. That's as much as I can see from here. We're going to have to get this stator cover off and take a look at this one-way clutch. It's got new gaskets on there, so somebody's definitely been in here. I'm going to go ahead and pull the spark plug out of this thing to release all the compression. You definitely don't want to continue to run this thing in any way, shape, or form without this supports on the outer covers. Alright, let's give this button a tap, see what we come up with. Just as I thought, the starter is driving the reduction gear, driving the idler gear, and then driving the one-way clutch, which has failed. So this thing has multiple problems. Now I've seen these before where the auto decomp spring has failed and fallen off the camshaft. So what happens is this is not from one of these, this is from a Suzuki. But the idea is the same for the most part. It's got a spring that returns the flywheel weight back to its original position, allowing the thing to decompress. When these springs break, this could potentially stay flung out, causing this thing not to want to crank with the starter, but it will start with a pop start. And if this particular bike has this problem, which I don't know yet, this could be an issue why somebody kept hitting the starter, and it just burned out the one-way clutch. So that's something we're going to look into. A good thing with that is it's a pretty cheap fix, like $1.49 for the spring. Alright, so I'm struggling with this rotor to the likes. I've never struggled with a rotor before in my life. First part of the problem was the threads on it were botched up for whatever reason. They don't look bad, but I just could not get my puller, my remover tool, to thread onto it. So I ended up starting to use one of my large pullers, and I stripped the threads right off of it. This thing's destroyed. So where I'm at now is I've got a smaller puller on here, and I've been kind of beating on this thing a little bit and hitting it with some blaster and a little bit of heat, and it still is not coming off. So I have to get this thing off to replace this one-way bearing in the back of the flywheel. And we're going to go ahead and replace the flywheel like we saw when we took it apart, that it had some dings and dents and damage to it. So we're going to replace that and go ahead and replace that one-way bearing. Also, this needs to come off if we need to get any access to the timing chain or anything like that, which, you know, kind of actually feels a little bit loose. But if there's any kind of issues with timing or the chain being bad, because remember, he did say that this thing had a bog or a running issue. So I have not heard it run yet. I want to be able to get access to that if I need be. This is so crazy because there's nothing that holds this on. It's a tapered fit. That's all it is, with a keyway. Wow, this is crazy. Boom. Now, I really don't like putting any kind of pressure on the crankshaft. I had no choice in this situation. All right, let's get a filter in this thing. So we're getting oil up to our journals. That's always a plus. All right, got it back together. Let's see if we can hear what this thing sounds like if she starts up. Cycle the fuel pump a few times. All right, let's see. Sounds like our battery's pretty low. I put a little charge back on the battery. Let's prime up this fuel pump. And let's see if she'll start up. There's the enrichment knob hiding. It sure don't sound good. Wow, is that loud? Probably should have done this while I was apart, but I'm going to check the camshaft timing on this and see if she's wacky-doo. Alright, camshaft timing is right on the button. Let me go ahead and check the valve clearances. So this exhaust valve, I can't even get a 0.10 millimeter in. This is way too tight. 0.15 on the intake. It slips right through. And it slips right through. 0.18. That's tight. That's tight. So I'd say the intakes are probably in good shape. The exhaust on these, I believe, is like 0.17 to 0.22 or something like that. Let me go with a 0.15. Barely gets in there. This one's not going in at all. Let me go look up the exact measurements on this before I go any further. Alright, just as I thought, 0.10 to 0.15 millimeter on the intake, 0.17 to 0.22 on the exhaust. So I've got a 0.15 here, which is smaller than the minimum, and that will not go in there. And it really struggles to go in there. So both the exhausts are far too tight. We need to go with a next size smaller shim as a minimum. Let me see if I can get anything under this exhaust. 0.08, and that won't even go in at all. .06, this thing's so flimsy. And that won't go in at all. So I would say this is definitely going to be an issue for him. This thing will not stay running. The valve clearance is too tight. As it heats up, it's going to just keep getting tighter. So it's holding this exhaust valve open. We're going to have to shim these if he wants me to do it. So as it turns out, my customer's going to go ahead and just do their own valve adjustment. So I guess we'll just pigeonhole this video into an electrical starting diagnostic endeavor, if you will. So that's going to do it for this one. Thank you all very much. Appreciate all your support, and we'll see you on the next one.